Also, no, we said we'll come and do question 3. Question 3b. We're still on question 3. B, f of x is equal to the modulus of x for 1, 2. Now the modulus of x, for differentiation's sake, we are safe if you write it in this definition and then differentiate it that way. So we get half x squared negative half multiplied by 2x. This is going to be, the 2's will cancel, and so we'll have x over the root of x squared, which is equal to x over the modulus of x. And then when we get such, we hold a bit, we go and check. Or we differentiate before checking if the conditions are satisfied. So I need to show you how to differentiate this one. Now let's go and check if the conditions are satisfied. That will allow us to proceed. F of 1 is the modulus of 1, which is 1. F of 2 is the modulus of 2, which is 2. So since f of 1 is not the same as f of 2, and these guys are not equal to 0, then the Rolle's theorem is not satisfied. It does not hold in this case. Okay. C, the function h of x is equal to 2 the power 2x plus 1 minus 3 multiplied by 2 to the power x plus 1 in the interval -1, 0. How do we differentiate the exponents? Try it on a very simple number. Let y be equal to a to the power x, and then apply ln on both sides. Apply ln on both sides. So we know that on the left we have ln y, on the right we can write this as x in a. And then differentiate ln y, we get 1 over y, but because it's y, we have dy dx. Differentiate x ln a, we get ln a. And so meaning that dy dx is equal to y ln a. So what does that mean? Dy dx, the standard now, is going to be, what is y? Y is a to the power x ln a. This will always be the derivative for such functions. So when we come here, we are dealing with 2 to the power 2x plus 1. So the derivative of that piece is going to be 2 to the power 2x plus 1 multiplied by ln 2 minus 3 ln 2 to the power x. Since 3 is just a coefficient there, so when we apply this, we'll get that. Okay, so we differentiate before checking if the Rolle's theorem are okay, because I was really interested in showing you how to differentiate. Let's now check what is h of -1. 2 neg 1 plus 1 minus 3 2 neg 1 plus 1. This is the same as 2 to the power 1 minus 3 over 2 plus 1 when x is -1. So that we get what? We get 2 down, then 4 minus 3 plus 1, giving us oh, you see the mistake. There's a mistake here. That this is going to be 2 to the power -1 minus 3 2 to the power -1 plus 1, which is the same as 1 over 2 minus 3 over 2 plus 1, which is 1 minus 3 plus 2 over 2, which is 0. Then if you test h of 0, we'll get 2 to the power 1 minus 3 plus 1, which is 0. So it's satisfied. And so we can go back to h and look for a c, which is going to be 2c plus 1 ln 2 minus 3 ln 2 2c is equal to 0. If we divide throughout by ln 2, we'll remain with 2 to the power 1 multiplied by 2c to the power 2 minus 2 to the power c multiplied by 3 is equal to 0. What I've done here is, since we are dividing throughout by ln 2, we only remain with 2 to the power 2c. We remain with 2 to the power 2c plus 1 minus 3 2 to the power c is equal to 0. But when the powers are adding, it's the same as multiplying 2 to the power 2c multiplied by 2 to the power 1. The minus is still there. So we'll have 2 to the power 1, this is just 2. And then you can choose to write 2 to the power 2c as 2 to the power c, the 2 outside as a square, minus 3 2 to the power c is 0. Then we pull out the common thing. So as you can see, 2 to the power c is common. Then we remain with 2, or in simpler ways, you let p represent 2 to the power c, so that the equation becomes 2p squared minus 3p is equal to 0. And then you factor out p, you have 2p minus 3 is equal to 0. So it's either p is 0 or 2p minus 3 is 0. So p is 3 over 2. Then you come back to what is p? P is 2 to the power c is 0. This is not possible. But 2 to the power c is 3 over 2. This is very possible. All we need is to apply ln on both sides. Ln 2 to the power c is equal to ln 3 over 2. If we drop c, we will have ln 3 over 2 over ln 2. If you set this, if you punch this in the calculator, you get that this number is in between 1 and 2, which is the required C for the Rolle's theorem. Do we have questions here? So because of the test that is coming after next week, we'll also have a session tomorrow. Then next week we'll have sessions from Monday up to Friday, so we're able to finish the tutorial sheets in preparation for the test. Now, if you saw how your quiz came, it gives you an idea that it's not just about solving, it's about understanding the theorems. Meaning that where there's a need to go up to the theorem, you need to understand the theorem. So that if he goes in the theorem and asks you a question, without asking you to state the theorem, you must be able to understand that the statement of the theorem comes into play here and use it to get the solution. Because without understanding the theorems, it's going to ask you, without telling you that you're doing the Rolle's theorem, you put a question that demands the statement of the Rolle's theorem. So it's up to you to see that, oh, since it's defined, differentiable, and continuous, I can apply the Rolle's theorem here for me to get my solution. Have a good night.
All right. Thank you, sir.
Yeah.
Okay.